This episode of Gauging Quality is sponsored by PQ Systems, developer of GaugePack, the original gauge and calibration management software. For more information, visit pqsystems.com.
Well, welcome to Gauging Quality, the show about gauges, calibration, measurement best practices, and more. I'm your host, Dirk Dusharme, Editor-in-Chief of Quality Digest.
And I'm Craig Howell, President of CPM Labs in Rancho Cordova, California. Today we're going to take a practical look at practical considerations when implementing a calibration program at your facility. And
be sure, anytime during the show, if you have any questions for Craig, they won't be for me because I'm not the expert, he is. Be sure to just send them to techno-live@qualitydigest.com. You should see that at the bottom of your screen there, techno-live@qualitydigest.com, and we will get to your questions probably at the end of the show, but who knows? If they're interesting enough, we may just throw them to Craig right there in the middle. So, Craig, so what are we talking about today?
Well, the decision's been made to implement a calibration system at your company. So we're going to take a look at some of the factors that can happen beforehand, some that happen during the process. Pretty much it's a series of activities to get all your gauges in a system that'll work.
So when you say system, this is, for some reason, maybe ISO 9001 requirement or something, all of a sudden now they really have to be tracking what's going on with their gauges and have proof that they're got a system in place to make sure that everything's calibrated when it should be calibrated and so forth? Is
True. It's a series of activities usually driven by a specification, ISO, ANSI, one of the AS specs, or it'll be a customer requirement. In order to produce their product, you have to have your tools in a system, not just a haphazard calibration, but an actual system.
Okay, go for it.
All right. So the main question we get right away, we like to meet with customers before they take this step and talk with them about some of the ideas you can use that'll help you. Well, first thing is, what tools need to be calibrated? Does everything under the roof need to be calibrated? Typically, no. There will be the tools that are used to accept the product, and then there will be reference only. So how do you decide which are reference only and which are used?
And what are reference only tools?
Reference only might be more of a stand that holds something rather than an actual gauge that gives variable measurement, things of that nature.
Okay.
So where do you start? You'd start with the specification that you're working to or the requirement and see what they say. All of them have one thing in common. They will all say anything used to accept the product must be controlled and in a calibration system.
Okay.
Some of the specifications actually will say anything used to demonstrate product acceptability. That could be a torque that's done in process. In other words, more of an in-process check. If the specification says that, then any tools used there will have to be part of the system.
Okay, so just so I understand the difference here, we're talking, there would be like an inspection gauge that might come at the end just to verify that, okay, the product is final, but something like a torque, like you said, torque wrench is, you know, the spec says a screw's got to be tightened or a fastener's got to be tightened to a certain inch-pounds of force. Mm-hmm. That also has to be...
That would have to be in the system. Maybe it's going to be covered up later. Maybe it'll be a process that'll be machined off, or some way they won't have another chance to check it.
Okay.
So that would be how you could differentiate between what would be reference only and what will be actually in the system.
Okay.
So that would be one of the first things, is what tools. Next question we get asked a lot, or what about personally owned tools? Do they have to be calibrated?
Now, is that very common? I mean, so it sounds like you're saying you might have somebody who prefers to use their own micrometer or something, right?
It's very common. Most inspectors will have their own set of tools, that sort of thing. Most machinists will come with tools. That's part of the trade, typically, is having the tools. So the question is, do they need to be calibrated? The answer really is, it doesn't matter who owns the tool. If the measurement being taken or the process being recorded if it has to be recorded, yes, it has to be. It doesn't matter who the ownership belongs to.
I can see where that might be a problem. I mean, I've known guys, and they're very territorial about their tools, and if you come to them and say, well, you know, Jane, we're going to have to take your set of tools and send them off for calibration, it just seems to me that I could see a little hesitancy there but it's a requirement. I mean, you got to do it, right?
You do, but there are also different approaches they can take. Some companies will approach where everything used on the floor is calibrated. That is one approach. Another approach for people who might be reluctant to let go of their tool would be a set of shared calibrated inspection tools that are shared by 3 or 4 machinists. They'll use their tools to get you up to the point of making the measurement. Then the actual measurement is taken with a calibrated tool. Where that can end up being a problem is if the tool the individual's using of their own is so far out that they machine something undersized. You can't add metal. That could be a problem.
And it also seems like it'd be almost kind of wasted effort too. If I'm measuring with something that you can't really use in your final process, then you're measuring twice. It seems like in some cases that would be almost a waste.
That would be. Sometimes it's just used up to getting near the point, like the final cut will be checked with a calibrated tool. Right. So that's one method. Some methods, they'll actually have in their procedure a stop point where the production will stop, and due to either their specification or the customer's requirement, an inspector will come out. It'll be a second set of eyes, a second check that they will come out and calibrate, or actually measure the part using a calibrated tool. Okay. So that assures that a calibrated tool is used for that checkpoint. Okay. And that's always it's always good to have another set of eyes.
Sure.
So that is another approach. Very common will be everything on the floor is calibrated. They will just end up taking tools that are not calibrated and removing them.
Yeah, and if you don't like your own tools being used, then don't bring your own tools.
Don't bring your own tools, right. Yes. Okay. So those are some of the approaches on which tools and should personal tools be calibrated, that sort of thing. Some of the strategies that companies will use when they're undertaking a program like this, some of the different things that we find that can be wasteful. Let's take a production line. Sometimes some production lines will be using something like a thread gauge in their process. And we just did one where they actually said, well, the production line is going to be shut down while we calibrate their tools. So the person came over with the thread gauges in hand, and they asked, can we wait while you calibrate these taps? Now that was an indication right there to me there's probably going to be a problem.
So you mean you're saying that they basically only had one?
They only had one in this situation, and that was a problem. When we get a tool in, we like to clean it, we like to let it sit and normalize. There's quite a few processes happen before we calibrate, and they don't happen quickly.
Right.
So they were shut down while we were doing this sort of thing. Of course, the tool ended up measuring drastically out of tolerance. Now the production line was stopped.
So you're saying, so not only was there a delay, a normal delay, because you have to let the tool soak, and then you have to do whatever you need to do with it. Mm-hmm. So there would have been a delay anyway, but the delay was exacerbated by the fact that then the tool ended up being out of spec and they couldn't even use it. So now what? They have to go out and buy it.
They have to purchase one now before the line can start up again, where these are not that expensive on critical processes, and that would be identified in that meeting I spoke about that we like to get together and talk about. The critical stages, which could be like a bottleneck or a shutdown, have 2 sets of gauges. It's well worth it to have one. They can be using that one while we're calibrating the other one. If there's an issue, it's not a panic. It's just replacement time.
And maybe only for, like you said, those particular steps in the process where it's critical.
Right. Yeah, you don't have to do that for every tool, but it's pretty easy to identify with a little forethought. Yeah. What will happen. Another situation would be, we had one situation where there was a pressure gauge used on a line, and the line couldn't be shut down too long. The pressure gauge had to be calibrated and put back. They didn't have time to send it into our lab, that sort of thing. Understandable. Again, buy 2. Because this was a safety situation where we had to have 2 technicians go out, 2 technicians on site at your facility, and it's going to cost significantly more than if they bought. It wasn't that expensive of a gauge. They could have bought another one, sent it to us beforehand, had us calibrate that. Then it's just a matter of the maintenance person swapping them out.
Yeah, and then it's just a regular calibration. They send it snail mail to you. You do your thing, send it back. Less cost than you coming out to them.
Much less cost. So these are areas that a strategy can be made where it'll be to your advantage.
Okay. So
those are some of the strategies. Another strategy might be if you have multiples of the same tool. Most shops have 5 or 6 0 to 1 OD mics or 0 to 6-inch calipers. Don't give us all of them at one time. You're probably going to be splitting it up biannually anyway, so give us half of the micrometers. This way you're not shut down while you're waiting on us to calibrate.
And what's the reason for that?
Some companies want to do it all at one time so that they know everything is in date.
Okay.
Everything is calibrated in date. Others might have a situation where they have trouble getting the right tools at the right time, so they just make it a one-shot deal. This March will always be calibration month.
Okay.
That sort of thing.
Right.
But if possible, split them up, and this way people can share for that 1 day a year we come in, or 2 days a year we come in, and the department keeps running.
Okay.
So those are good strategies that'll help keep you running while we're there doing our business.
All right.
So what are some of the good shop practices that can extend the life of the tool? Thread ring gauges are used quite a bit, and usually they're threaded all the way onto the part. Sometimes the part will only stick out a little bit, so the thread ring gauge is only used for a portion of it. Over and over and over, it'll wear. It's called a bell mouth. It's shaped like a bell, the way the wear is. Well, every now and then, while you're using the gauge, flip it over and use the other side, so you'll get a little longer life out of the tool.
Same thing I think you've told me applies to like surface plates. Don't keep working
Right.
at the same spot on a surface plate year in and year out, right? Because you'll actually
Yes.
wear down that section
area,
of the surface plate.
And
Okay.
whenever you move it, we say rotate it 180 degrees. It's
Okay.
almost like a standard de facto. Put a piece of tape on the front, and when you move it, make sure you can't see the tape anymore.
Okay, all right. So basically, kind of spreading the wear out as much as
Yes.
possible
That
on
will
any of
help.
your tools. Yeah. Okay.
The other most important one you all know is clean the tools. Keep the tools clean. It's not just because you will get much better measurements, but also a lot of the dirt and grime is abrasive, so you'll wear the tool down. Not only will you be getting false readings, but you're wearing the tool down. They'll wear out a lot faster if they're dirty. Coolant proof. We get some coolant proof calipers and indicators that are brimful of liquid. I think they've been soaking them in that. Coolant proof means if a splash of liquid hits it, wipe it off and know that there's no problem.
Doesn't mean they're immersible.
No, they are not immersible.
All right.
So those are some of the things that can help extend the life of your gauges.
All right.
Now we get asked a lot about calibration interval. What's the proper interval? And the proper interval, there are usually factors that come into play with it. One would be the stability of the tool. How stable is it? Is it a steel right angle plate, or is it an indicator that has basically a watch movement in it? They're going to wear at different rates. They're going to need different calibration intervals.
And so this is going to depend, I'm sure, from one facility to the next. For the same tool, the calibration interval could be vastly different, right?
That's true.
Okay.
And the manufacturers will have a suggested interval when you buy them, but that's an average. They can't know your situation. They don't know if you're using it once every 3 months or if you're using it 24/7 on all 3 shifts constantly. That would be a different interval. You should review your calibration certs you get from the calibration lab, and if they will always have how they were received and how they left. How they were received is critical to this process of deciding. You have to decide the interval. We cannot. By specification, the calibration lab cannot decide the interval.
Now, one of the ways of determining the interval is looking at your
history.
Your history of calibration, right? Because you could see, well, every time I bring this in, it's well within spec, so maybe you could extend out your interval?
You could do a history review and extend it out slightly. If every time it comes in, it's found out of tolerance, that's a clue that your interval is too long.
Okay.
You should consider shortening the interval, because the questions become, and this is usually defined in your quality manual, how far out was the tool? How much did it impact your product? Was it just an academic out of tolerance condition, just barely out, and your engineering team will say, well, that's been designed in, or is this significant?
Well, let's talk about this a little bit, because this is critical. So you have a tool, you send it in for calibration, someplace like CPM Labs, you guys get it, and you find that it's actually maybe significantly out of calibration. That means that tool has been used on the floor somewhere to measure and certify the accuracy of a part.
Of a part.
Okay, and now we don't know whether that part was actually within or not, right?
It goes through a whole process once the tool is found out of tolerance. From your end, you're going to be reviewing what was it used on, how far out was it, what direction, what's the magnitude.
So the calibration, I'm sorry, the quality manager is going to get a report back from CPM Labs saying this tool was out by this much, and that person, the quality manager, let's say, has to make a decision of, well, what parts were tested with this, how critical was this measurement, what, maybe do we have to recall these parts and recheck them because that's a critical dimension? I mean, there's all sorts of things that go into place if you know a gauge was out of spec, right?
There's a whole process involved, yes, and it can be a significant problem if the part was implanted in somebody, if the part's in an airplane that's flying. You can imagine the different scenarios. So, okay. Right, significant, when something's determined significantly out of tolerance, and you will have that defined in your quality manual typically, that unleashes a whole new set of procedures.
Okay.
So that is another factor on interval selection, on keeping a company from saying, well, 1 year, let's just increase it out to 2 years. How long has it been out of tolerance? The only time you really know it was in tolerance is the last time it was calibrated. Right. You're guaranteed it was, but
yeah. So if you've extended it by a year, you could have a year's worth. I mean, up to 2 years, or yeah, exactly.
Because you had a year, now you have 2 years. Yeah. So the questions arise, and okay. The interval selection. The worst one you can give an auditor if they ask is it was based on financial considerations. If 1 year is good, like 3 years must be even better.
Right. Right.
So an auditor will never take financial considerations as being your basis for selecting an interval.
Okay.
So that was on the selection.
Now we had some question also on you buy a new tool and you have a certificate of conformance versus what a certificate of calibration, right?
Right. We get asked that quite a bit. They'll say, can we use the calibration cert that came with the tool? It depends.
Okay.
If it is a full-up calibration cert, certificate of calibration, not a certificate of conformance.
And what's the difference between the two?
Certificate of conformance is typically a little bitty sheet of paper that'll say this tool was manufactured in conformance with how we said it was.
Okay.
And that's just the company guaranteeing to you that they made it as they described. That's not a certificate of calibration that won't stand up in an audit. Okay. There are certain things you need to have. You need to have a statement of traceability to either NIST or some SI, some standard units have been, something of that nature. You'll usually have data in some form saying it passed all the parameters it's supposed to have.
So you could buy tools, I mean, I'm assuming most tools, you could buy them pre-calibrated though, where the company says, what, for an extra fee, we will calibrate your tool before we send it to you, right?
Right. A good example might be the cylindrical pin sets that you see, the 11,000s to 60,000s, 60 in a box to 50 in a box, 61,000s to 250. Those come with the little certificate of conformance, the one that's not a calibrated cert. If you bought it with the calibrated cert, you'll know because it costs significantly more and it takes a little time. They don't stock those on the shelf with the calibrated cert. They actually measure them.
Now, does this make sense? I mean, you buy a tool, they calibrate it, but then it's shipped to you via Monkey Express or something, and do you know that once it gets to you, it's still in calibration, or does that just kind of vary on the tool?
It would vary on the tool. You'd be pretty safe with something like a gauge block that is a single piece of material that's packaged in styrofoam. It's going to arrive to you in the same shape it left, or you'll know if the box.
Yeah, or something solid like this. Yeah.
Something with a delicate movement in it. Something with some very, very high resolution electronics. That would be the gamble.
Okay.
So a lot of customers, even when they buy the calibrated cert, will ask us to take a look at it. They'll send it through us and then into them.
So you'll take a quick look at it.
Quick look, functional check, make sure everything makes sense. Everything is working the way it's designed.
Okay.
Which is really one other thing on the calibration interval on establishing it is how delicate is the tool, how accurate is the tool. Something that measures in 1/1000th of an inch will have one interval. Something that measures in the single millionths typically will have a whole separate set, a whole different interval.
Right. Okay.
It just has to go that direction.
Alrighty.
So probably we should get to some of the questions that we have received. One of them that we did receive was a question that was asking us about how to handle plain cylindrical plug and ring gauges.
Okay.
What's the best approach? And let's go back again to the box of the Meyer Vermont pins, those types of pins, because that's a very good question. We have to prep them before we can measure them. Let's go to the gauge cam. I'll just give you an idea of the areas that we look at. Typically, the front edge will have all the nicks and dings. Now, this isn't exactly one of those tools we were talking about, but this is the same style. So we have to clean them, we have to deburr them. There's a lot happens before the actual measurement process. And if you have 5 or 6 sets of these with 1,000 pins in each, our time is going to be significant. There, a customer might say, let's just buy a new set rather than have them recheck all of these. And they'll say, we can buy a new set for what we're paying you to prep these. And we agree, you could. And there are certain things we can't do that a new set will be very shiny. It'll have a wonderful surface finish. It'll glide in and out of the holes. After they get grooved and nicked, we can remove the raised metal, but we can't restore the surface finish.
Right.
So their buying new makes sense. Now, new is not calibrated, like we just said.
But I would assume that if they sent you, even if they wanted you to calibrate that pin set, right, that it would still be faster than calibrating an old set, because like you said, it already comes there, it's shiny, it's new, it's going to be faster than you having to clean the tool and deburr the tools and so forth before you test them, right?
It's much faster, and really they'll, depending on the people using them, they'll have a much better feel for the product they're measuring with it.
Okay.
So we do agree with that. If you have a bunch of old sets, it costs quite a bit to buy new, but it's going to be, you're going to pay somebody. We're going to have to charge to deburr them, and then what do you end up with? You get a deburred, grooved, nicked pin. So we do suggest considering buying new when you have sets like that are in bad shape. You can usually tell if you see the plug and there's a hammer or a file near it. You can usually have an idea of what's going to be involved.
Well, I would assume this is true for pretty much any kind of gauge, though, right? I mean, there's a point where it costs more to repair and calibrate it than it would be to buy a new one and even have you calibrate it.
That's true.
Okay.
So those are some of the considerations on the different sets that you might buy.
Okay.
On individuals, we brought along, I'll go back to the gauge camera again, we brought along a cylindrical plug gauge that's a double-ended, has 2 different ends. I have one sealed and one unsealed, and it's usually inserted into a hole. So we will measure it and certify it. When they go bad, typically the gauge is popped out and they replace it with a new one. Some of them have an actual holder and a collet where you can reverse it, and the back end will be inside the handle at this point. You'll reverse it around the other way, and now you have a new gauge, basically.
Okay.
That's for a plain plug gauge. Ring gauges, plain cylindrical ring gauges, are a little different situation. A lot of times they will come in with a calibration cert on them. They're typically class X, class XX. A lot of times they will have a calibration cert, and that would be one of those tools you could buy, calibrate it, and know it's going to be fine when you get it.
Right.
They're used differently. They're not usually put into things. Usually you will, a lot of our customers use it to set an internal micrometer, an intramic. So the type of wear we see, again, we'll see nicks and edge damage, but a lot of times we'll see grooves down inside if they haven't cleaned off the intervals of the internal micrometer and they're reaming it up and down while they're getting their number.
Let's talk about that. You said some, you told me before that some facilities or some processes are more prone to causing damage to tools, and I think you said like where they work with ceramics, right?
Right. Ceramic wears tools like nothing I've ever seen, and they're machining or grinding the ceramic. The dust will be in the air. The tools will get them just sitting there. I've seen an optical comparator that they have a series of 2 mirrors inside of them. The bottom mirror was pure white. I almost thought it was a new design, but no, it was just ceramic dust
that had gotten over it. Well, and I think so. I think you said with something like this, if the person is using an internal mic to measure the diameter, and you've got ceramic dust, every time he puts that internal mic in there and moves it, he's going to be scraping away at unless he's cleaned off both the micrometer and the object at the same time, right?
Right. He'll be reaming some grooves right in. Now, one of the processes, I'm going to hold up we brought a large ring with us. The manufacturers will recoat and recondition these. It doesn't cost as much as buying new. They'll do this on both plain rings, and they'll also do it a lot on thread ring gauges. It is one method of doing it because it's not as expensive as buying new.
Okay.
So there is some hope. If they're out of tolerance, you don't necessarily have to throw them away, but they will have to be. They'll have to address that.
Before you get to the rest of your gauges here, we had a question that came in. And remember, if you have any questions, send them to techno-live@qualitydigest.com, and we will get to them. So if I can see that question. I have a set of thread ring gauges, which, strangely enough, so do we. I noticed that when I verify them with a master set plug, one side of the ring is tighter than the other. What do you recommend?
That's a great question. We get that a lot.
And we just happen to have a set here.
We do. Now, what happens is when this is threaded onto the part, as we said, sometimes it doesn't thread all the way on, and it will bell mouth on one side. It's typically used one-sided. People don't seem to get through their head that you could reverse it. So they have worn one side quite a bit. When it's calibrated, this is a very special type of thread plug gauge. This is called a set plug. It's not used on the product. It's used for setting rings. We will thread it on, and the very first couple threads when it goes on, it'll shake like crazy on a bell mouth side. You flip the ring over, and you won't notice that at all because there is no wear at that.
So you're saying that this person's issue is most likely because they kept using the same side every single time.
Right. And the only cure for that is reconditioning, because if you tighten the adjustment down, you're going to make it too tight all the way in.
Right.
You can't really correct for that. That either has to be replaced or reconditioned. You find that a lot in no-go ring gauges. Customers will ask us, how can a no-go be rejected? It's made to just start and stop immediately. How can it be rejected? Well, it gets used over and over and over, and it wears bell mouth where it's not going to give you a true reading.
You know, I was trying to think, why would this only get worn on one side, and it dawned on me. I can think of just a psychological reason. I picked this up. It has let's say, a calibration sticker on this side. It might be just my habit, put the calibration sticker toward my hand, and you just, oh yeah, this is the way I pick it up. Oh, calibration sticker's over here. I'll thread it from this, and you just get used to picking up the same. You don't even think about it. It's just, that's the way I pick it up. And so you don't get used to flipping it. Like you said, you should be trying to think about flipping it over.
A lot of times, all of them are marked with the thread size on it. So somebody will pick one up and they'll say, okay, is this the 3? Yeah, okay, then, this is the one, and they'll immediately go on. It's just a matter of thought. It can extend the life of your gauge. I have an idea that's what's happening to that person is it's a bell mouth condition, and any good calibration lab or thread manufacturer will be able to verify that.
Okay. Let's go on to our...
All right. So some of the questions...
Oh, that's right. Yeah, we did have some questions that came in before the show. If we can put up the first one there, Christopher. Is the use of rounding and significant figures commonly practiced and acceptable during standard inspection?
All right. I have an answer for you, and I hate to say it again. It depends. It does depend a lot on what you're actually doing. What are the specifications? Are you measuring to a blueprint? They might have ANSI specifications. They handle rounding. When rounding is required one direction or another, they have a specification. IEEE has a specification, ASME, they all have different specifications. Likely your quality manual should define when you have to round, how to round. We're used to the old school method a lot where 0.5 and above of that last figure rounds up, 0.4999 and down rounds down. That's not always the case in industry. Sometimes they will say truncate, remove the last digit, forget about it. Doesn't matter if it's 9 or if it's 1, remove it. They want 3 decimals.
Okay.
One of the ANSI specs, let me read it just so I get this exactly right. It will say that if a feature would violate the original intent, you cannot round, such as a ceiling. Let's say a plug has to fit in a hole. If it needs a certain amount of clearance, as soon as it goes above that number, it doesn't matter how little bit above, it won't fit anymore, or it won't have the proper clearance. Rounding isn't something you should do.
So what would you do in place? I guess that's...
As soon as it violates that number, as soon as it goes above, you reject the part. You don't round it down and say, well, it's still really only 0.5000. As soon as it becomes above 500, no matter how far out you go, as soon as it becomes above, it's out.
So that'd be a case of rounding down, where if it was...
You don't round at all. You don't reject.
You just reject. Okay, I got it.
Right.
Okay. Yep.
Other people who do like statistical analysis on a batch of 1,000 parts, they want to see how a machine's running. The old rounding that 5 up every time is not accurate. ASME has a method where what they do is you round that last figure up, you round it up if it's 5. If the number there is even, you round to that number. Say 0.5555 and you're rounding it up, it's 556 now.
Okay.
You would round up. If it's an odd number when you round it, you leave it alone.
So if it was 5554, you would leave it.
You would round. Let's say 5. Well, too many numbers here.
Okay.
If it rounds to an even number, you round up. If it rounds to an odd number, you don't round up.
You just leave it. I get it.
And
okay.
the reason
right,
is statistical analysis. You'll get a bias if you're doing 1,000 parts, and every time you get that 5 as last digit you round up, you're going to have a bias that direction. This evens it out. In our line of work, we don't, because we're not doing batches of parts, we're doing individuals. So we would not round. We will report out and let the customer choose to round. One advice they do give on rounding is don't ever round until you're at the very, very, very final equation. If there's any other factors you have to put in there, don't round because you're throwing in bias already. Wait until you see that final equal sign, then you would consider your rounding.
Okay. Before we get to the next question, was there something you were going to show us on these, on the thread gauges? Because I don't think we got into these, did we?
Oh, we did a little bit. Some of the things that we will see. Let's go over to the gauge camera again. I'll show you what do we find wrong with thread gauges. A lot of times we will find nicks right on the threads, and that's going to keep a properly adjusted thread gauge, be it a ring or a plug. Let's use a working plug. If there are nicks on the gauge, that will reject the gauge. It doesn't matter what the size is, it's not going to fit in the hole.
Okay.
On the other hand, the no-go, which is supposed to stop immediately, if it's stopping because of a nick, that wasn't the intent. So anytime nicks or grooves are present, that'll reject the gauge. These thread gauges are adjustable. Some are, some aren't. Typically what we will do is there will be an adjustment screw here. We'll thread it on the set plug and adjust it to where the pitch is a good firm fit on here, and then it will have to clear the full form. This is a specially made plug.
Right.
So what happens is when this has been adjusted too many times, this round feature becomes oblong shaped like a football, then it will not clear.
Okay. Now, you said this gauge, this thread gauge is a little bit different in that it's got an extra adjustment in there. Talk to me about
right.
that.
Most of them just have the one adjustment screw at the top here that you'll see. That will lend itself when you tighten it to that oblong shape. This one has an additional adjustment screw on the bottom end, and it counteracts that oblong, so it's trying to keep it as round as possible.
So you're saying that as you adjust this, you're kind of squeezing this in, which would tend to kind of squish in the sides of the, and then this will kind of come in from the other side and kind of try to even it out. Okay.
Right.
But not all makes do that.
No, that's a very special type that do that. Most of them do not.
Okay. Let's get to our next question here. Pop that up. When we measure threads between our suppliers and ourselves, we both order the same type and class of thread gauge, but they can pass parts and we can reject the same thread. Can you explain why this is and what are some ways to improve alignment on thread inspection for both fixed and variable data?
That's a good question. We get a lot of thread ring gauges. Now the specification, I don't like the way it's worded. It says to thread it on the set plug to a firm fit.
A firm
fit. That could be different from me to you to the customer. One customer may be setting their rings themselves and saying that's firm, where another customer would say that's not even clearing. I've got to use undue pressure to get that on there.
That's firm, buddy. Yeah.
Right.
Okay.
So that's where these are called fixed gauges. The setting is called a fixed gauge, where you're setting it that way. Different people will have different feels, and there's tolerance within the setting plug how much it's allowed. Yours could be on one end of the tolerance band. Your customers could be on the other end of the tolerance band. Really, one of the methods would be to have both sets of gauges calibrated by the same calibration lab.
Well, let's back up a little bit, though. I mean, with a fixed gauge like this, I can understand, but with a variable gauge where you have like some sort of micrometer tool that goes in, if they're having the problem there, then it's not a matter of is it what's firm, it's maybe just what expertise in measurement? Expertise. I mean, just operator differences?
Right, which there are different methods for checking Gauge R&R, that sort of thing.
Yeah, I mean, we're going to get to this later, but this is, I think this is one of the issues you're talking about, is that you've got two different sets of equipment. I mean, they've got their equipment, you've got yours, you have your operator, they have their operator, and there's all sorts of permutations on the variables between operators, between equipment and so forth.
Their environment.
Their environment.
If their environment is controlled, or if they're checking it right by an open warehouse door.
And that could lead to there being differences on why one would pass and one would fail, right? And this is, I think, and we'll find out more about this later, but I think that has to do with what Gauge R&R is all about as well.
I have a feeling you're right.
I have a feeling I'm right, okay. If we can get up in I think a third question we got here. And by the way, remember, got any questions, now's to start shooting them to us, techno-live@qualitydigest.com. Okay, oh yeah, I remember this one. Do you know of any equipment to record variable data when checking internal thread features, that is, major, minor, and pitch diameter? The more types and possibilities that could be provided would be better. I emailed back and forth with this particular person at their company. Their situation is that they have a lot of different types of internal threads that they want to measure, and they're using a top-of-the-line internal thread measurement device, a system from a very well-known company, but their issue is they've got to have a different I guess a different gauge or a different fitting for every single thread they got. And he says, you know, you got hundreds of these things, and the cost is just exorbitant because you don't have one tool that kind of does a range. You've got a separate tool for every single thread you've got.
The cost is huge on those sorts of systems. They usually consist of a frame and some sort of a holding device. Then they will have different sets of inserts. They're usually based on the pitch, a 12 pitch, a 30 pitch, a 32 pitch. You have to buy separate pitches. Each set costs quite a bit. And then another key, even within the same pitch, if you're measuring a 1-inch 12 thread, you're going to have a different master to set that gauge up to than if you're measuring a 2-inch 12 pitch. It's not variable like a dial caliper or something of that nature. Right. They're so accurate, they have a very limited range, so you have to set them to something. That something is a master. That master
those will measure both major diameter and minor diameter.
They'll always measure pitch diameter. Pitch diameter is something that's always measured. A lot of them will measure either the minor diameter. Some will measure all three: minor, major, and pitch. But they're very expensive. They're very good, but I can't think of a low-cost alternative. The only low-cost alternative I've seen are the ones that go on, that bolt onto a caliper, and I can't speak to their accuracy. They're probably not going to be there.
So I think the answer to the question was, and if I understood the question right, this person was looking for a tool that would measure, let's say, a range, a range of size of threads, probably the same pitch, but over a range of diameters. One tool that would do that and measure major, minor, pitch. And pitch, of course. And from what we can find in talking to one of the large thread measurement companies, they said that kind of is the holy grail of internal thread gauging. And as far as they know, they don't exist until you get to larger, smaller size threads, no. Larger size threads, they say that there probably are, I think he said starting at 2.5 to 3 inches inside diameter, that you do start to find tools where that might be able to measure a range of internal diameters. But
it gives you so much more information than a fixed gauge will be a pass-fail.
Right.
Where actually on the internal thread, the fixed gauge will give you a pass-fail, where the variable you can see, it's also great for UNS, UN special, because you may not have a thread ring gauge of that size, or a thread plug gauge of that size, where you could then take the variable data and work it from there.
Okay. See, did we touch everything we wanted to touch on before we get to our Gauge R&R?
I believe so.
We have any questions? Any more questions coming in, Christopher? Nope. Okay. Okay. So one of the questions that we got prior to the show, we got a couple of really good Gauge R&R questions, and Craig and I went back and forth and realized that neither one of us knew a whole lot about Gauge R&R. So we thought we would try to find somebody who was an expert on Gauge R&R. Unfortunately, just happened to be, really it was a coincidence, that our sponsor, PQ Systems, happens to have a guy on staff who knows all about Gauge R&R. So rather than Craig and I flubbing around pretending we know what we're talking about, we decided to bring on an expert. This is Eric Gasper from PQ Systems. Hey, Eric.
Hello, gentlemen. How are you doing this afternoon?
Pretty good. How are you?
I'm doing very well. Thanks for having me on the show.
Sure. Well, Eric Gasper is a trainer and technical support expert from PQ Systems. Before we get into the Gauge R&R questions, can you just give us kind of an overview of what Gauge R&R is and what it is trying to accomplish?
Sure. A lot of the information that Craig was discussing so far has been all about calibrations, which is going to be answering the question, is this particular gauge or tool, is it accurate, or is it within my tolerances? And that's certainly a question they want to answer, but an R&R study can take that a bit further. It can identify other areas of variation in your entire measurement system. So questions about one company is using a particular tool and they're getting good parts, another company is using the same type of a gauge and they're getting bad parts. So that question there is, what is the difference? An R&R study can help identify where those pieces of variation are coming from. A lot of it could be the different gauges themselves. It could be the people that are using the gauges. It could be the method that they're using to work with the gauge. It could also be the environment. Is there a heat difference, temperature, magnetic fields, dust, vibrations, lots of different pieces that you would want to try and figure out. And an R&R study is an experiment that could hopefully help identify where those variations are coming from.
So it's looking at the data, measurement data across different operators, but all using the same tools.
Correct. In a typical R&R study, you're going to be taking one tool. You're going to have a couple of different appraisers. These are the people that are usually using that gauge out on the shop floor, and then you're going to be getting a sample of some of the parts that they're typically going to be measuring. So a typical study, you might have 1 to 3 appraisers. You're going to be using the same particular measurement tool, and then you're going to grab some samples from your regular production line. So it's an experiment to try and repeat the same conditions and process that you're normally doing your measurements with. Now, once you complete a study, you can actually examine and take a look at some of the different calculations, and it could give you a clue as to where the most amount of variation is coming from, where it be it from the tool itself, or being from maybe the appraisers, and then you could have a discussion with the people who are using the tool in an attempt to make the process better, make your entire measurement system better overall.
Okay, so one example of this might be when Craig was talking about, and I get these confused, plug gauge?
Yes, thread plug gauge.
Thread plug gauge, where one operator's idea of firm and another operator's idea of firm could be two totally different things, or is this more related to actual variable measurements where there's actual numbers involved as opposed to touch?
Well, it's actually going to play in for both. You can do an R&R study based solely on variables measurements. You can also do something called an attribute R&R study where it's going to be mostly for pass-fail. But you'll actually find when you're reviewing your results for an R&R study that you can identify which appraisers do have a soft touch versus a light touch. When you look at all of the data for all of their measurements, you'll see that some appraisers will be consistently low and some will be consistently high. And that could be an indication on how hard they're cranking down on a particular tool. It could also be that that person's maybe never been trained on the correct procedure. So all of those things go into figuring out where that variation is coming from and then creating a plan for correcting it.
Okay, so let's get a couple to the couple of the specific questions that we had on Gauge and R&R, and if you can put up the first one there. When measuring in inches, what kinds of things do we need to be able to be able to pass a Gauge R&R less than 20% for 4 and 5 decimal places?
Okay, that's actually a great question.
And
The first thing I'll make note about, depending on...
Before we go
Sorry,
there,
go ahead.
tell me first of all what that meant, less than 20%. What does that mean?
Well, when it comes to the guidelines of an R&R study, there are usually a couple of things that you want to take into consideration and kind of like an overall grade, like on a test. The typical guidelines are that any percent R&R that's less than 10%, you're doing rather well. That's probably going to be a pass for almost any company or any industry. Between 10 to 30% for your R&R, that's going to be marginal acceptance, meaning you're probably going to have a discussion with either the customer or your auditor to determine if that is going to go ahead and pass. In this particular question, they're asking about less than 20%. If I were to get an R&R study with 20%, I'd probably be happy because it's within that marginal acceptance, but I would still come up with a game plan for making some improvements. So that way the next time I do my study, I'm now shooting for a lower score. And that's going to tell me that, yes, the changes I made were successful.
Okay. So sorry to interrupt there, but back to the question.
No, not a problem. So in regards to the question about when you're using a tool and you're measuring in inches, and you're measuring to the 4th or 5th decimal place, the resolution of a gauge could definitely play a big part in your overall results. However, it's not necessarily critical. If you're measuring maybe only to the 1st or 2nd decimal place, you can still have a good R&R study, but that largely depends on the parts that you're measuring. If you're measuring some critical pieces with very, very little variation, then using a tool that will measure out to the 4th or 5th decimal place is probably what you're going to want to use. To answer the question in general, though, as far as a recommendation of things you might want to consider when you're setting up your R&R study, I would say first focus on the part selection themselves. What you want to do is get a random sampling of, say, about 10 of your parts that you're normally making. And the reason why you want to get a random sampling is because you want to see if there's variation in your system, and you also want to see if your gauge and your measurement system can identify when the parts are different. So if I wanted to go about this, I'd probably focus on my part selection. You could start gathering your parts usually a couple of weeks in advance, so that way you are getting a random sampling. Or, and this is a tip that comes from the inspection division of ASQ, you can actually, while you're doing your regular measurements, if you find some of your parts are close to your tolerances, just hold those back and that'll be part of your study group.
Okay. Before we get to the next question, what is and this is just my own ignorance here, of which there's plenty, what is the difference between measurement uncertainty, which I know is somewhat related, I think, to Gauge R&R? Are these two related in any way, or one's a subset of the other or something?
They can be considered part of the same suite of experiments. There's a couple different MSA, which is just measurement system analysis studies that you can conduct. Gauge R&R is one of them. It's actually one of the kind of larger ones that companies will actually participate in. But there's also a number of other ones, specifically an uncertainty test. The typical setup for this is you're going to be taking one gauge with one person, and you're going to be measuring a part over and over again, probably about 15 to 20 times. What you're looking for here is an average. And the uncertainty is going to be, are you having a high number on average or a low number on average based on the reference value of that part? So if I have a 6-inch part, and I know it's a 6-inch part, and I'm measuring this continuously, I'm going to be looking for that average to see if it's significantly high or significantly low from what that known reference value is. Now, a couple of other studies that you can conduct, and this is actually something that you were discussing earlier, is the idea of a study to determine if your calibration interval is going to be the best one moving forward. And Craig gave a good answer, saying, oh, it's going to be right from the last time you did a calibration, but something like a stability study, that could be used as soon as you're done with the calibration. You're going to be taking measurements periodically, probably every other couple of days with a known part. And as soon as you start to get measurements that are not close to that true value, that could be an indication that you need to do a calibration, either shortening or lengthening that calibration interval. So there's a number of different studies in R&R, uncertainty, stability. Those are all part of a suite of studies that you can do to answer a lot of questions about your gauges. Okay.
We had another question, I believe, on Gauge R&R. Well, we may have already touched on this. Is 20% reasonable for a passing value on a Gauge R&R at 4 and 5 digits?
Yes and no. I have to kind of almost give an answer that Craig kind of mentioned to earlier. It depends. Now, the general guidelines are between 10 to 30% for your R&R. It's going to be marginally accepted, but it largely depends on the industry that you're adhering to or a standard that you might be adhering to, and also the customer. If a customer requires you have an R&R percent that is less than a certain percent, then that's what you have to adhere to. If I were to receive an R&R study results that is 20%, I would still make plans to make adjustments, or at least investigate where that variation is coming from, come up with a plan, talk with my users, implement the plan, and then I would do an R&R study again a few weeks later to see if that change made a difference.
Okay, and what are some tools? I'm assuming this will be kind of a shameless plug for PQ Systems, but that's okay.
I'm fine with that.
You're fine with that. So I'm assuming there are software tools, of which I'm sure PQ System, Gauge Pack has. What are some of the tools that are useful for doing these kinds of studies? Is there just a Gauge R&R assessment tool or that sort of thing?
Yes, there are a lot of different types of softwares that can calculate your results. Typically, in the olden days, what you'd have to do for an R&R study was usually a couple different pieces. The first was preparing your study, meaning gathering all the different parts, your samples, finding the right appraisers, scheduling the time to go ahead and do the study, and that was all the administrative work, getting things ready to conduct your study. The second step would be actually conducting the study, and there's a couple of tips and regulations and rules that have to go with it. And then finally, you'd have to actually calculate the results. So you have all of your study data. Now we have to figure out those percentages. Well, luckily, software will take care of that step for you. These MSA studies, these R&R studies, they're really just forms that you're filling out. So you can take a study and do all the results by hand, but first I'll tell you that it's going to take you a while. You have to double check all of your math, and there's still a possibility you can make a mistake at the very beginning and not ever catch it. So the benefit of using software is it makes that step very, very quick, very easy, and it's also very accurate. So there's a number of different software out there that can do R&R studies. Our program Gauge Pack, it can definitely take care of that for you. So again, shameless little plug, but still.
Okay.
I would say moving forward, I don't know of any company that's probably doing these studies by hand. That would just take too much time.
Okay, thanks, Eric. So stay on the line with us, Eric. We'll finish up here in a few minutes if we don't get any more questions. So remember, if you got any questions, while Craig and I are just kind of recapping here a little bit, send your questions to techno-live@qualitydigest.com. They can be questions for Craig on what he's covered, or on another Gauge R&R question for Eric. So just, if you can, Craig, let's just kind of recap just the main points on setting up a calibration system, a proper calibration system within your company. What are just kind of the high spots there?
Okay, the high points, the bullet points I would say would be which tools should be calibrated and which will be reference only.
And we said basically any tool, regardless if it's a personal tool or a company tool.
Ownership makes no difference.
Okay.
Which tools should be calibrated, what's the proper calibration interval.
Which we said depends.
It would all depend. What are the requirements from either your customer or the certification that you're working to?
Okay.
So those sorts of things, and usually a meeting beforehand to strategize, to figure out where are the bottleneck points, where should you have two gauges, that sort of thing.
Yeah, and just to kind of recap on that, kind of some of the important things we were talking about was making sure that you had duplicate gauges for critical processes, so that you're not dependent on one gauge tying up your process when you send it up for a cal. Okay. There were a couple other things there.
Certificate of conformance versus certificate of calibration. The little bitty sheets usually won't fly.
Right. You want a certificate of calibration. And also, I think you said from a lab's point of view, you would prefer to get all gauges of the same type, like all micrometers or all calipers, as opposed to a mix, right?
We'll be able to get more tools calibrated at your facility at one time if we're batching them, if we're doing micrometers at this point in time, and then doing calipers, not doing one micrometer, one caliper, one indicator. That's not efficient. We can do it, and sometimes you have to. Sometimes the department has to shut down and be be taken care of. So.
And I think finally also you said spreading out when you send your tools in over the course of a year, not just gathering everything up all at once and shipping it off, right?
If possible. If you have more than one of exactly the same type, send half of them.
Okay.
So those are good methods.
All right. Well, Christopher, any more questions? Nope, that's it. Okay. Well, Craig, once again, thanks for your expertise. Eric Gasper, thanks for joining us on the show and answering questions about Gauge R&R.
Thank you very much for having me.
Hey, no problem. Okay, well, that is our show for today. Again, it was sponsored by PQ Systems. For 30 years, PQ Systems has provided quality control software and training to help people in manufacturing, healthcare, government, and service organizations demonstrate proof of their quality performance. Visit www.pqsystems.com to see the full range of products and services that PQ System offers. So once again, thanks to all of you for joining us on Gauging Quality. Craig Howell, Eric Gasper, and we will see you again in actually a couple months for another Gauging Quality. So long.
Thank you for your questions.
Three, two, one, fire.